Hi, welcome to my YouTube channel. This is Ramnath Mani, bringing insights on industrial automation from the past as well as the present and what we can expect in the future. In today's episode, I bring to you an interview with Mr. Dennis Brandl, the founder and chief consultant for BR&L Consulting, specializing in helping companies use manufacturing IT to improve their production and logistic processes. In this interview, I am joined by Lee Pryor, another veteran of industrial automation industry in the US. Dennis has been involved in automation system design and implementation in a wide range of applications over the past 35 years, with heavy focus on MES and ISA 88 batch control system and ISA 95 enterprise control system integration areas. He is an active member of the ISA 95 Enterprise Control System Integration Committee. He is co-author of MESA B2MML standards. He is a member of the ISA 99 Cyber Security Standards Committee. He is the former chairman of ISA 88 Batch System Control Committee and has also participated in the development of OPC and other industrial standards. Dennis has written numerous papers and articles on business to manufacturing integration and flexible manufacturing solutions, has a regular column in manufacturing IT issues in control engineering, and has authored the book Design Patterns for Flexible Manufacturing and has co-authored the book Plant IT, Integrating Information Technology into Automated Manufacturing. In February 2013, Dennis was inducted into the Control Magazine's Process Automation Hall of Fame, and in 2008 was listed as one of the leading thinkers in manufacturing technology by Managing Automation. He has a BS in Physics and MS in Measurement and Control from Carnegie Mellon University and a MS in Computer Science from California State University. Hi Dennis, welcome to my YouTube channel. It's a pleasure to have you in my channel. And I think we can start with your background, early days in industrial automation and experiences thereafter.
Okay, my background is I've got a BS in physics and a master's in what's called measurement and control, which was 1974. Now, we didn't have something called robotics in 1974. So measurement and control was computer science, digital electronics, and physics at the same time, trying to solve problems. So my thesis work was on equipment, but our project was to retroland a rocket, several years before Elon Musk, but we didn't get real rockets to play with. We had, fake some of that. But my first job out of college then was actually to work on the US space program, the space shuttle program. And they had hired myself and another one of my colleagues there that went to school with to basically get them up to speed on computers, because at Carnegie Mellon University, we were using computers for everything. We were using them to, like I said, retroland rockets, control trains, etc. And we didn't realize the rest of the world wasn't quite like that. Hadn't gone that far. So they hired us in to use the computers to test the space shuttle program and test various satellites that were out there. So we were testing the space shuttle, we were testing satellites. We had mini computer systems. We had set up networks, early networks. Again, we're talking 74, 75 networks, distributed computer systems, because we had clean rooms where we had the space shuttle and the parts, and actually the very last Apollo-Soyuz flight. And then a mile away, we had the computers that were big mag tapes spinning and displays, something that looked, very science fiction-y at that point in time. So that was kind of how I started. Out of college, went into this. The computers we were using, the old ModComp computers, I ended up going to work for them after a couple of years in Fort Lauderdale, and those were used basically for automation control. They're mini computers. For those people who are younger than us, mini computers are the size of refrigerators. They eventually got to the size of small refrigerators, but they were still pretty big and didn't have a lot of memory. I mean, we're talking about 64K, 128K, those sort of things. But people were using these computers for factory automation. There were steel mills, aluminum plants, chemical plants, these sort of things. So I've been involved in that side of it since about 78. And so we did a lot of work on those. Eventually, after that, I ended up working for Texas Instruments, Industrial Systems Division, which made PLCs, made the PLCs that drive and control a lot of systems. They eventually got bought by Siemens, so I worked for Siemens for a while. Then I went to work for Schneider, who had a different range of PLCs. And then for a small company, it's now out of business, doing batch control until finally I went on my own. So I've had a career in factory automation from probably 1978 on. And during that time, I've been involved in the development of multiple standards that really support this. One, the ISA 88 standard for batch control, ISA 95 standard for the MES systems, MOM systems, warehouse management systems, and then the ISA 99 security, cybersecurity systems as well. But I'm also, in ISA and do several activities there on the administrative side. So been in there for a long time. And I also, in the middle of all that, got a master's in computer science from California State University. So it kept me busy.
Wow. Great journey, I would say.
Very good.
You said you were connected with ISA in developing these standards.
Yes.
How advanced was it at that time? I mean, in the time, setting up standards when the industry was just growing. I mean, you had to have a lot of vision in order to foresee a lot of things. So
Yeah.
how was it? I mean, how was that experience?
Well, in one sense, it was a little difficult because I had a computer science degree. I understood computers. I understood how they were being used and what they were. But a lot of the older engineers there didn't really have that experience. So sometimes when we talk about things, we need to define it this way so that we can implement it. Those things were difficult decisions to make. And many times developing standards, it's much more about diplomacy than technology. You're trying to get people to agree, people from different countries, different companies, different industrial divisions or groups that they deal with. So you've got all these differences in there, and you're trying to come up with common languages where that they can all kind of agree to it. So it took a while. But we did that on the 88. It took us, quite a few years to get that one out. And then learning from that, we did the 95 work because we said, there's something that happens above a recipe control batch engine where the magic occurs. Something comes down from your business system, says, do this. How do we do that? That one went really well. As a matter of fact, there were some complaints from the IEC side of it that it went too fast. They didn't have a chance to review it enough. But lately, the latest one that I'd worked on right before COVID hit was the OPAF, the Open Process Automation Forum. Okay, and that's a brand new architecture for basically think of them as smart little nodes that are programmable, that all work together in an environment to execute control algorithms that can be distributed geographically or can be, collected together. There's a whole group going on building that and building those standards now and building the products based on them. I think that was kind of the continuation of all the work that we've been doing in some of these other standards.
Great. How have the international standards, let's say, you have the European standards, you have the Asian standards, the American standards. How are the applications of them, brought closer together and, which can be, today we talk about, the world becoming small and, everything is interconnected. At that point of time, the standards have to be practically the same,
They have to be the same. Take a look at it. We don't even have the same standards for electrical plugs.
Yes.
Australia is different from Japan, is different from China, is different from the US, from Europe, et cetera. So,
yes.
Yeah, it is a hard problem, but we do have many multinational companies that really kind of support the standards because they want to build the same things around the world. So they want standards that apply around the world. So many times in these committees, you've got companies that are saying, okay, yeah, we want an international standard, and they will hopefully compromise to get those international standards, not come in and say, hey, mine's the best, and they can go from there. But yeah, so that's part of it. And the other is that there are what we call liaisons, working groups that work in the IEC and ISO with the individual country standards organizations. So in the US, it's ANSI, the American National Standards Institute, works with this. ISA is an international professional organization, but it feeds most of its standard work in the US into ANSI, but then into IEC. So there's liaisons and working groups to try and keep these things together. Now, it has become much more international. We've got a lot more international support in all of these efforts. But as I said, it's diplomacy. It's not necessarily technology.
How is, IEEE is also another, set of group which works on, technology. And,
we don't drive much on IEEE in the factory automation world, except for the work that has recently gone in, which is the 2-wire Ethernet work that's going in. That's really one of the crossover points. And because a lot of industrial applications really need that 2-wire 2-wire Ethernet with power, which is also intrinsically safe, which from our industrial standpoint is extremely important. So there has been work going on that end of it, and on making Ethernet time dependent, time sensitive networks. So that work is primarily what we've been doing with IEEE. But for the other worlds, we tend to just ride on their coattails. Pick up the wireless, pick up the Ethernet, pick up all this other standards, HTTP, et cetera, XML standards that they have.
Do you see a shift towards wireless communication versus hardwired Ethernet?
Oh yeah, because the cost to run wires is extremely expensive. So if you can do it wireless, and now to a large extent it's sensors. It's not necessarily control. A lot of wireless sensors, especially on movable equipment or moving equipment, rotating type of equipment. We're starting to see a lot more of that. Even in the industrial environment, if you've got screens or displays or head up or handhelds, it's all wireless at that point in time. But for actual control, I want to control something, that still tends to be very hardwired. It will get to wireless eventually, but you still got to get power to the control element anyway. So you got to figure out, how you're going to do that. And again, with the 2-wire powered over Ethernet, maybe that will actually start to replace and pop in. Now, it's not going to happen until 2025, 2026, because the standards have just come out. Products haven't really started to drop out yet.
Is anybody building sensors with intelligence built in for control?
Oh yeah, absolutely. I mean, the old Purdue model, the old control models just don't apply anymore in the modern environment when you have so much computing power. I used to say when we built the systems for controlling refineries, we took a $1 million computer, which had 1 MIPS, 1 million instructions per second, 1 megabyte, and 1 megabaud of network throughput. And that was $1 million. I can't buy a chip that small anymore. And this, we're talking about 15, 20 cents sort of thing to get, almost 10 times that power in there. So yeah, people were applying that. Now, the key to applying that is to know what to do with it. And that's where some of these emerging standards, the MQTT that shows up, OPC UA shows up, all these other standards to be able to basically plug this device in, query it, find out what it's capable of doing, and then it can become part of your control system environment, so you can start to use it. And they will have the control elements built into it as they start to get there. So you'll have a little device. Well, today you can look at a valve. And a valve has not just the valve control, but it also has the sensors built into it to tell you what's actually working. That gets smaller and smaller, particularly in the discrete manufacturing industry. And honestly, in the biotech industry, where you talk about injecting very small amounts of material, so the valves and the control systems are actually pretty small.
See, one of the major problems that we have in India, for instance, is there's an ambient of nearly 50 degrees in many of the factories, which are all situated in the north. And, as you miniaturize your semiconductors, the heat dissipation becomes a very big issue. And, that could actually, prevent you from really taking on to the markets like in India. Have things, been sorted out on that issue?
There's a continual push to use less and less power in the ICs in the IC industry. I read the IEEE magazines on that all the time, and so you are getting less power constraints, and many times you can declock some of the chips to make them run a little bit slower. They're going to dissipate less heat associated with it. There's also again, I keep reading articles about more passive heat transfer systems that will be able to take that off the chip and put it out into the environment. Of course, your environment's still hot, but most of these chips will run at about 70 rather than 50. So you still have a temperature difference that you can use to cool these things down. But technology is advancing in that area.
Yeah, of course, I have seen PLCs, originally being all for 35, 45 ambient, working for 50, 60 degrees ambient.
Yeah. Well, and then also minus 40 degrees working for 50
40
years.
degrees.
Yeah. That's really, one of the questions that you had mentioned before was, what were the big changes in automation as things moved forward? And there were two of them, in my opinion, from what I've saw. One was the distributed control system, which let us replace manual control and operator controls with automated controls. In these are the Honeywells, the Fisher, even the Siemens, and these systems were really kind of a game changer, where you could take I have to be careful. You could take a drawing of what your control system was and then implement it. And then in the discrete world, the PLCs where I could take an engineering drawing that somebody can understand, a technician or somebody, and actually implement it in software. These were two graphical languages that were implemented in computer systems that retained essentially the graphical components of it, and you could actually look at it that way. Those were major changes because suddenly it opened up control and automation to a wider group of people who weren't necessarily computer science or software programmers or anything like that. They were engineers and experts in their industry.
Talking a little about PLC itself, there has always been a talk for many years, I know, that the PC will probably replace PLC, in some format, but it's not happened.
No, it has not happened. And part of the reason is this, you need something that runs at minus 50 degrees and plus 50 degrees. And you also need something that is stable over a long period of time, 5, 10, 15, 20 years. PCs, well, they aren't stable over 5 years. I already have several computers that are obsolete and we can't use them anymore. So if you want to build a system that's going to be stable, you don't really base it on a PC. Now, PCs offer a lot of advantages. So a lot of PLC vendors and DCS vendors are putting PCs into their environment. Plug them into the backplane or make them available, because there are some things that is hard to do on a PLC, hard to do on a DCS, but it's easy to do on a PC. So, but you have to be careful because those things go obsolete much faster than the dedicated control systems.
I understand.
So you're kind of alluding to or getting into one of the issues we always had in years past, which was all the different protocols that the different manufacturers came up with of automation products, PLCs. So there was no interoperability. I mean, it was at the beginning impossible. I won't say virtually, it was absolutely impossible unless you stood on your head to connect a Allen Bradley to a Modicon PLC in a system. So where is that going today? Whose protocols are dominating and what's happening in that area, Dennis?
I probably have a bit of an opinion on this one. The protocol that I see dominating is the one that is vendor independent, so it's not the Profinet, the MiceNet, those sort of things. It is the OPC UA Foundation network standard. Now, it'll ride on top of many different kinds of networks, but typically it rides on top of an standard Ethernet sort of network. The reason I'm saying that is that it has security built into it where the others have security layered on. Okay, that's very important. The other thing about it is that it is very much a I don't want to say object-oriented, but it's very much a system that you can query to find out what it's doing and what it can do. And the performance is comparable to the other networks. There's multiple modes of running it. There's an XML mode and there's a binary mode. The binary mode is equivalent to the other ones. There's a lot of work going on in VDMA, which is the German organization. There's a lot of work going on in Europe to build what they call companion standards. You say you take a piece of hardware and you write a model around it. This is what this piece of hardware can do. This might be something like, example I was working on one time, eyeglass, polisher. So what can I do with that? Well, I can set the curvature, I can set the size, I can do all these others. So you have an interface that allows you to set those parameters and to read those parameters as your test system actually looks at it. So I see OPC UA as becoming a predominant version of it, particularly as we move to the 2-wire Ethernet. It becomes a whole lot easier. The stack to actually run that, fits in these chips that we're talking about. Even small devices can now fit there.
Okay. Then, of course, I'm sure you're waiting for this one. What about artificial intelligence, AI?
It will be a big change, yes. But, I'm not sure that people quite understand nowadays. My kids work, my sons, who are all adults, they're all over in their 30s and 40s. They work in software. They will often use AI to generate the preliminary code to solve a problem. I think this is fairly common. People are starting to look at that. The AI will show up to say, okay, I need to control this thing. And it will give you a draft. I'm only going to say it's a draft, because this is it's still at the level of high school, but a draft of the control strategy you should use. And maybe it'll give it to you in a PLC format, a DCS format, or some format that's transportable. Now, that's using AI at the design side. That will increase the efficiency of programmers and people who are doing these control systems designs. The execution side, AI is primarily driven by training and by knowledge of what the system is. And we collect a lot of data in our manufacturing facilities. The only problem with that is that the data we collect is hopefully 99.9% always the same, because we want repeatable processes. So it's not like they're learning the problems and to recognize the problems, because they may not see it. I've been in refineries, you can go weeks or a month before you actually start to see a problem. And so it's hard to train an AI on that. So you have to use things like simulation and others to train the AI. And then you're never quite sure if you've actually trained it that way. So I see a while before it's actually starting to show up in actual direct control. It will show up in analysis, though, because we collect a lot of data about what actually gets produced. Every widget that gets produced, you may have 15 photographs and 500 measurements on that unit that just got produced, and you're producing lots of them. So you've got a big data set there. So I see AI showing up in analysis. I see AI showing up in design. I don't see it showing up in control just yet, because it's really so hard to train them.
Okay.
My own view on this was that, AI probably in the control, as you said, it's going to be very extremely difficult to implement. However, we do know that, in industries, especially in the process industries, the parameters have all been set up for a particular, product, and the way the specifications of that product. And we used to have in the early days an Excel sheet showing, a product and then all the parameters, and then we'll manually go and set it up. Later, it became a little more digital and, became a little automatic. Probably those are the things which could become, AI controlled, because there's a lot of data available for that.
There is a lot of data. And then you have tools that people use to model, the simulations, which are first order simulations. So these are in refineries and chemical plants and these sort of systems. And today we have many of those, and they already have some optimization built into that. They're trying to do some level of optimization of those parameters based upon your models. it's hard at this point in time still to keep the models and the simulations in sync with reality, because reality tends to change. And if somebody changes something, you may not always catch it in your simulation or your model. It could be applied there. Yeah. I mean, it could be applied that's the analysis side of it, really, the analysis to say, okay, I need to set new parameters. I need to, change the run rate. I need to change the speed of this motor, these sort of things, to reduce the number of errors or reduce the downtime on the machine, something like that.
What about the merger of factory floor systems and integration with enterprise systems? Is that advancing? I mean, are people actually able to take a bill of material? And this is something Manny and I were working on with the SAP systems. Take a bill of material through scheduling and everything, and then send it down to the factory floor and have all the machines do their thing. Is anybody able to do that?
Yes, we've had people do that. And it works perfectly well until something bad happens. Some system gets attacked. So the current strategy, as proposed by the ISA 99, which is a 64223 standard, says you really need firewalls. You need to protect this. The data that you send down is data that is, what you're supposed to do, but it's not a direct command. You're not really directly commanding these systems to do something. You're giving it information that it can use to determine what to do. In many regulated industries, what comes down from your business level systems, if it doesn't match what you have validated already, you can't use it. So and in some really tight control systems, where I call them the boomable industries, where things go boom in case something happens. In those cases, you always need to have some intermediate check. It could be automated, it could be manual. It simply says, take what I got from my business level system and make sure it makes sense with what I currently have here. Now, in the 95 standard, we talked about that. We talked about the levels of information and the details that you actually need to actually execute it. Now, there's some industries where you don't need a lot of extra detail as you go down to production. For example, making beer, it's pretty straightforward in the sense that what you get coming down, you can actually implement quite often. Making a pharmaceutical or a biotech product, no, you get a request that comes down and says, here's the bill of materials, the materials that I need, but there's 10,000 steps you have to execute to actually get there. So the best thing is firewalls, pass the information, let the lower level make the actual tactical decisions on how to use that information. The ERP sets the strategy, the lower level sets the tactics.
I remember the early days, we used to have these control cables and power cables running more or less together. Mm-hmm. And you had to take a lot of care because there would be, as they say, noise, which could create a lot of disturbances. Now, of course, all that is of the past. And, we have the internet. And obviously, it has got another type of threat. I mean, cyber security threat.
Cybersecurity.
How does one actually tackle that now and going forward, especially with the hackers and all are absolutely on rampage? So,
Yeah, well, industrial cybersecurity is not something that you do and you're done with. It's a life cycle. Basically things continue to change, particularly as you get updates and changes and as people discover new vulnerabilities and those sort of things. But there are good recommended practices. And a lot of those practices, some of these practices deal with technology, the firewalls, et cetera. But a lot of the practices deal with policies, procedures, and training that you have to have in place, because quite honestly, most of the attacks that show up because of human error. Somebody clicked on a link, or plugged a USB card in or something like that. And so you got to have policies, procedures, and tests in place. You got to have firewalls that give you levels of protection. So if one part of your plant actually does get infected, it doesn't infect the rest of it. It's a continual effort. Now, the way to look for it is to find those products that have security built into them, which now that doesn't mean they're secure when you put them in. That means you can enable security and turn it on. You have to still configure it. You as the owner are still responsible. They're supposed to give you the tools to make it work, but you have to apply those tools correctly.
I understand.
One of the things that I mentioned when Manny was interviewing me that I saw happening near the end of my active time at Schneider was a lot of tension between the IT folks and the factory folks.
Yeah.
Has that has that has that gotten any better, or is that still an issue in many
it hasn't
organizations?
it hasn't escalated to active warfare yet. But that being said, no, there's almost always in most companies that tension that exists. And part of that tension exists because we are using standard IT tools in many times, particularly for the servers, the databases, the HMIs, the human machine interface systems, these sort of systems that are in the factory floor and actually part of the operational side of it. So we're using those systems, but then the IT folks say, "Well, it's a computer, it's a server, it's a PC, it's under our control. We'll reboot it right now." It's like, no, you'll shut down the plant. So yeah, there is a continual tension, and that tension exists until such time as somebody, either an OT or an IT side, usually IT, shuts down a plant. And then they realize, oh, we have a severe problem. We got to do what was recommended, separate these systems out. I was working on one company where they decided to do ping checks on networks, but they did it randomly. They wanted to find out what was on the networks to see if there was any invalid equipment that was out there. So they didn't tell anybody about it. Well, unfortunately, even though this company had policies and procedures to keep these networks separate, they never had any systems in place to guarantee that people were following the policies and procedures. So what happened is these pings would come out, they'd be hitting all the different devices. It would hit an older PLC and shut the system down. And nobody knew what was going on. It's because it was happening at random times because the IT folks were doing it and not telling anybody about it. And everybody thought that the systems were separated, but they weren't. So that's why you not only have the policies, the procedures, you have to have the controls in place to ensure that you're actually doing that. But the IT, IoT folks, there will be continual tension, but it will not, I don't think it will escalate to active warfare until, somebody shuts down a plant and causes $5 million losses. Yeah.
Can you tell me something about, the OPC server on one hand and the MQTT on the other? They seem to be at sometimes competing with each other. Sometimes, they're parallel to each other. I think for a little better understanding.
Yeah, they solve different issues, quite honestly. I mean, the OPC UA and the OPC UA services are basically trying to expose object-based information and all the related relationships between that information to a system so that you can then query it and go to it. The MQTT is a simpler system, and you have to look at the data structures inside there and know a little bit about it. It's not as self-querying as an OPC UA. It is simpler, and in many cases, that's all people need. There probably will be no single solution in the world. OPC UA is primarily industrial, and so its market is always going to be smaller than what MQTT's market is. So MQTT will probably always be a little bit cheaper.
Coming from MQTT, now of course a lot of talk is going on unified, namespace.
Yeah.
you and it seems to be the
that seems to be it is a common buzzword, unified namespace. Yes, it simply requires that everybody agree to my standard, which is and unfortunately it's not my standard, it's your standards, your standards, your standards, all these stuff. I think it's a wonderful goal, but I have very little belief that it would actually ever happen. We can't even do it with languages. Come on, and even within districts within countries, we can't always do that sort of thing. Is it soda or is it pop? I don't even know. Which one do we want to call it? So it's a great idea, but I think it will always be a federated namespace, which means we will have individual namespaces in individual areas and some way to relate those things together, but not necessarily to say, I'm going to go to my plant and change all my tag names to match the federated namespace tag name. That's just going to be near impossible to do on some of these facilities.
from everything you're saying, it sounds to me like uh, if a tire manufacturer picks a PLC for a new factory, that's probably going to be it for the foreseeable future. In other words, the competitor that wins that game, that one is going to be the dominant player in that factory until they either shut it down or completely revamp it. I mean that
Yep.
was true. It's been true since you and I started in the business.
And it's still true now. Yeah.
Okay,
Mm-hmm.
so there's
Yeah.
not really much intercommunication between manufacturers going on.
That the cost of switching is too high. But, and
Right.
I'm going to throw a but in here. That was one of the aspects that the OPAF, the Open Process Automation Forum, was trying to address. Simply the fact that when you pick a vendor, you get locked into that vendor. The goal of OPAF is you don't get locked into that vendor, that there is a standard set of interfaces, that you can plug things in. I'm not sure if they've got to the point yet where it's a plug compatible, but we were working on it prior to COVID. But the idea there is that you can take out one system and replace it with an equivalent, which may come from a different vendors because it has passed all the standards tests. And in this case, it supports the programming language, it supports the configuration, it supports all that. Architectures may be different inside, but the interface to it is the same. That's the goal of OPAF. And this came from many of those large companies that had put in systems 20 years ago, 30 years ago, and are still putting in systems and looking at like, how can I update this without rip and replace, without doing the entire system? Think of the old Star Trek where you used to plug in modules to the computer and they would become active as you plugged them in. Same idea as you basically can take a component out and replace it with something which might be faster, it might have much more memory, it might have more capabilities, but at least functionally has the same functions as the one you just replaced in. And as you do that over time, your system can become faster, have more memory, have more capabilities, and more functions for you to do. That's what OPAF is really working toward, and they're working hard toward it.
In the past, if you take the past, you have these, traditional automation companies like Rockwell Automation, Siemens, or you can take Yokogawa or any of these companies, ABB. Now has, and then, next, the new range of people with a lot of IT built in have come in. So is there any change in the, you can say, composition of these automation players, how they stand respectively, compared to what they were earlier? In terms of,
what we're seeing a lot more, the problem with many of the big companies is their history. They have to live with their history. You live with the past mistakes you made. No, I don't want to call them mistakes. I'll call them mistakes. The past mistakes you made, and then you're living with that for an extremely long period of time. Why do we have a QWERTY keyboard? It's like because they needed to slow down typewriters because they would jam otherwise. So that's why the layout of the keyboard is the way it is. So that's a history that we live with forever. So because they have that history, they're limited in the choices, constrained in their evolutionary path. So you end up with a lot of smaller companies that are popping up that are doing things. Again, Ignition was one of those Sepasoft or other examples, but there's other examples out there. They don't have the history necessarily, so they are able to take a more I don't want to say an IT advanced approach. They can apply more of what we know in computer science and software engineering to their products than some of the older companies are if they're trying to continue to be compatible with their older systems. Because I know that having worked in multiple of these companies many times, living with your history can be very expensive and very constraining in your evolutionary path of that product.
Let me just raise a point that has been going through my mind for the last couple of years as I've gotten older and older. And I look back, I think Manny helped bring this in focus for me by interviewing me, that I don't think us in factory automation have made enough point of this, but we have improved humanity with factory automation. I often have discussions with people who don't know about factories, And, they say, well, robots and so forth. And I say, look, I go back to the days of paint booths with people standing there with masks and paint guns versus today. Those people were subject to all those fumes. Later in life, they suffered health problems. Same thing with people on the welding lines with the big guns hanging down from the ceiling. Today, it's all robotic, and you don't have to. People aren't exposed to the toxic gases. But I don't think that we in factory automation have made enough of a point of this to the general population. Especially as I look at, I was just thinking about this when the longshoremen went on strike.
Yeah.
And one of their things is they don't want any more automation.
Which is the most short-sighted thing you could think of, but in my opinion. But yeah.
Okay, so it's really not very smart. I don't want to say stupid, but it makes their life so much better and safer on a dock to have automatic systems.
Oh, I know. They're using them in other countries.
I think we need in our business to have made more of a point to the general population about the fact that it improves human life.
Yeah, I agree with you. And not only just improves human life, most people don't understand how much it has improved their lives, the individual lives. It used to be that 50% of the US population worked in manufacturing.
Right.
Now it's less than 10. We're producing like 3-4 times more than what we were ever producing there. We have situations in many companies where you can build the entire world's supply of a product in a single plant. And the only reason they don't is because of earthquakes or hurricanes or something like. So you want to have multiple sites, but we are so efficient at production and manufacturing today, and much of it is I want to say hands off, where the operators are monitoring devices, they're not operating devices. So maybe we need to change the word from operators to monitors to move that forward. Yeah,
and the ultimate.
I agree. It's we don't do a really good job, but I think people are starting to see that. They're starting to see automation in other places. They're starting to see their little Rombas, going around the room, cleaning the floor. They're starting to see their auto drive cars driving for them. They're eventually, if Elon Musk is right, they'll see their robots in the house folding your laundry and doing your dishes and these sort of things. Those are automation as well. So
yeah, but that's a little bit of scary about it is that where do people find jobs? As human beings are eliminated and taken over by robots.
Well, yeah, and that is that's always been the problem is that there was a famous story about the candle makers in France. They said, okay, we're going to go on strike because we want to ban the sun because it's keeping us from having our business. That doesn't work. This change is going to happen, whether we like it or not. It's going to happen. We are going to be much more efficient. We're going to make much less pollution. We're going to use a lot less resources to make stuff. And then what will happen with people? Personal services will become much more important, in my opinion. Okay, and these can be all sorts of things. Like it will be a long time before I have a robot that replaces a carpenter or a plumber or an electrician. Right. Or something like that, or a maintenance tech. I mean, maybe I'll have an assistant as if I'm doing maintenance. But the bottom line is you're still going to see a lot of service industries, and that's going to become even bigger because somebody has to work on these systems and fix these systems and install those systems and answer the phone calls when somebody's grandmother can't figure out what's going on. Those sort of things. So yeah, there will be new jobs. There will also be jobs monitoring these systems and taking care of them. That I think is what will happen. But we are removing from industry, and I call it the 5 Ds: dirty, dangerous, delicate, which means it's very fine to do, dedicated, detailed, and I can't remember the 50. Dirty, dangerous, demanding. Demanding attention all the time. So demanding attention, dirty, dangerous, detailed work, and dull. So Those things get replaced by automation. Nobody really wants those jobs. Okay. Yes,
Right.
everybody can start at McDonald's by flipping burgers and making fries, but some of those are going to disappear too. Unfortunately, those are the entry level jobs. So you're going to have other different entry level jobs that show up. Again, I'm looking not this year, next year, or the year after that, but much
Yeah.
more future.
I think there's also a great amount of emphasis being laid on sustainability, ESG governance, and all those things, which should make things even better as we move
It
along.
should, yeah. And I look forward to the day where we get completely recyclable plastics done. And I mean, there's lots of work going on, lots of industries, lots of universities and others to do that, to come up with the appropriate plastics that are strong enough and last long enough for the purposes that we have, but that you can easily break down and then reuse. That's because the amount out number of plastics we use is based upon the amount of hydrocarbons we have. Obviously, if the more recycling we get, the less that we have to dig up the hydrocarbons for the plastics and the plastics industries. I'm hoping that moves forward rapidly. It will take a while. They have to be economically viable, but it will happen eventually. That much of what we today do not really successfully reuse, we should be able to reuse. Yeah.
See, the other concerns which has always been, in the mind is that most of the factories that run today are still on legacy systems. I mean, and all the development that's going on is on the legacy system. I mean, you're using the same old stuff that's there, and you're just trying to do something on top of that to get what you want. Do you think the change from that to a completely new factory automation, modern system will take place soon, or it's going to be very, very slow process?
I think as soon as all the gray-haired guys retire, leave the industry, you're going to have a bunch of systems that people are afraid to touch because they don't really know what's going on inside it. It was legacy knowledge that didn't get transferred. When those systems finally stop working, yes, then you'll have your replacement. But as long as they keep working, even if they're not as efficient as you would really like them, until something drives it, cost of electricity just tripled. Okay, now it's time for us to replace these systems. Unless something like that actually happens, it's going to be a while, unfortunately, because the systems are designed to run 20 or 30 years. Yes. That's their design life cycle, or actually even longer than that, sometimes. So. I was working in an industry where it was 50 years plus.
You're right. But one thing that concerns me always is that the younger generation, I mean, we are, of course, the old generation. We've been inside plants and we've seen factories operate. We've seen touched machines. Many of the younger generation people have hardly been into a factory, and yet they are controlling everything through IT and, saying what should happen, and they are advising people, that looks a little odd, but I don't know, I mean, how that will move.
Well, yeah, I mean, that's the case where you have to learn a little bit from the Army, and you need to send those people through the boot camp. You say, okay, you're going to be inside that factory. You're going to see how they run, and you're actually going to be an operator for a week or something on each of these facilities, so you can see what's going on, and if you make a change, what the impact would be. Yeah, there will be more of that, I think, showing up as we bring newer people in. We had a whole missing generation, essentially, of automation, because those of us here, we built these systems and everything, and then they were stable and they ran for 20 years. So suddenly there wasn't any need for these people. Now they're getting old. We need the newer generation of people who are involved in it.
Absolutely. There was a period when I think everybody went to IT, and we could hardly find actually resources for our factories. Nobody would come. Everybody would go to IT.
Now, I think people are starting to see that they're good paying jobs. Yeah, they're reliable and stable. Sort of jobs, and you have chances for advancement in it. So, I think people are starting to see that the IT, the approach, computer science, et cetera, isn't the only approach that's out there.
I guess kind of a final question for me would be, just looking out 10 years, what do you think factory automation will look like in 10 years?
I think
Much different than today?
I think it will be different today. I think we're going to have a lot more, again, plug and play. You know, right now you get a device that supports USB, you plug it in and it works. That's all. You don't have to do anything with it. You don't have that in the industrial environment. I think we're going to get much more of that. We're going to get much more sensing, not necessarily actuating, but a lot more sensing that's going to show up in systems. So you're going to have a lot more visibility into what's actually going on. And that's going to be around to everybody. They're going to pick up their handy dandy cell phone or tablet or whatever it is and see everything they need if they don't have glasses on that actually are showing them, projecting them into their ears. But the basic thing we have to do is still the same. You know, a guy I used to work with, a great guy, Charlie Cutler, he said it the same way. You know, the things that we want to do with factory automation are the same things we wanted to do 50 years ago. It's just now we can expect we can do it because now we have so much computing power, so much resources available, so much network available. We can do many things we didn't want to do. The basic physics and the basic chemistry and the basic biology, they don't change. They're going to stay the same. How we control those, we control environments for each of those things to actually happen. Those will stay the same, but the tools we use to do it and the expectations of our ability to do that control are going to grow. So people are going to want to know more about what their system is doing, not just at the low level, but across the entire system. How's my entire ecosystem running in my plant? You know, is there a problem because of something that is, you know, here, but the problem showed up somewhere else and cause it? I want to see that entire thing. So we'll have much greater visibility, much greater span of control. And that means that the automation engineers have to be more proficient in more things. They're going to have to know security as well as the programming environments that they're operating in, as well as the, I'm going to say MES type environments that they're operating in, the workflow environments they're operating in. They're going to need to know all of that. And my guess is a lot of the maintenance and other things is moving to much more replace. Just pull it out, replace it. You know, the systems will be designed much more for pull out, replace, and put a new one in. Older systems, you know, taking something out and put it in, it could be days and days of work as you have to unscrew things and remove wires and then revalidate everything went back together. So I see so the maintenance activity becomes faster. You have less downtime. But you have to identify what the problem is. So it's going to be interesting there. That's all. I wish I could say I knew what was going to happen in 10 years, but if I did, I would be rich.
Very good. Thank you.
I think,
Danny?
Dennis, I think it's been a wonderful talking to you. I mean, you know, because we got the insight into the past, insight into the present, and insight into the future. You know.
Thank you.
and it was really excellent having this talk with you and understanding. And I think, you know, we should interact a little more as we move along and, you know, probably, I mean, look at things as they keep changing. And
yeah.
I'm very happy that, you know, I could talk to you today. Thanks to Lee. And
well, thank you. I appreciate the chance.